Welcome to the last video lesson for our unit on ratios and proportions, and this one is on the slope of a line. This is going to be one where we're going to kind of do a little of it here in 7th grade, but this is going to be a huge part of your 8th grade math curriculum next year. First thing to talk about is what is slope? Slope is simply this. It's the rate of change. I think of it as how quickly a line is going up or down. So you're talking about the graph of a line, so it's either going up quickly or going up slowly or it's going down or whatever it might be, but the slope is just how fast it's changing, its rate of change. Slope should always be written as a fraction in simplest form. So down here we have 4 types of slope, okay? I like to think of them kind of like ski slopes a little bit as far as how fast it's going up or going down. But when you go from left to right, if it's climbing up, kind of like you would like your grade to kind of keep improving over time, that is a positive slope. As you're kind of moving to the right, your values are increasing, it's going up. If you're going the opposite way, you're kind of going to the right, but everything is dropping down. That is a negative slope. Next one is kind of a straight flat line. I think it was kind of like the world's most boring ski hill. You're not going up, you're not going down, it's just flat. That means it has 0 slope. It's not going up, it's not going down, it's just flat ground. The last one we call undefined. It's a vertical line, and the reason it's undefined is because it's not moving left or right at all, so you can't quite figure out what's going on. It's literally just falling straight down. So this one isn't a 0 slope, a flat one, but it's called undefined. It's a straight slope going straight down. Slope is calculated this way. You find the vertical change over the horizontal change. So oddly enough, this is really challenging to remember because we're always used to taking the x first and then the y. We're used to when we plot points, we go over on the x and then up on the y. Slope changes things. We're going to put the y on top, the vertical change, how much it's going up and down, over the x, which is our left and right. So the easiest way to remember it is the little phrase, rise over run. And then the letter m is always used to represent slope. So m, or slope, is how much did it rise over how much did it run. So it's the change in the y value over the change in the x's. And that's really all it is. It's just how much did it change. So let's find the slope of each of these lines. Start on the left-hand point. So I always think of like reading a sentence. You start on the left and move to the right. We're going to count how much did it rise and how much did it run till we get to the next point. So you always try to look for 2 points that land right on the intersection of lines so we know exactly where they are. First you count the rise. So it went up 1, 2, 3, and then went over 1, 2. So it would have a slope of 3 over 2. That's it, rise over run. Down here, it went up 1, 2. It went over 1, 2, 3, 4. So we'd say 2 over 4. But because it's a fraction, we always simplify it. So we call this 1 over 2. Next one, you'll notice this one is going downhill. It's a negative slope. So again, from left to right, it went down 1, 2, 3, 4, 5, 6. So we call that a negative 6 since it went down 6 and then went over 2, 1, 2. So we'd say this has a slope of negative 6 over 2, rise over run, and then we simplify it to be negative 3 over 1, which is just negative 3. So sometimes the slope is going to simplify out to be just a nice, neat whole number. But it's always rise over run. How much did it go up or down over how much did it go left and right? So using that information, we can actually use our slope to help us count. Remember, the number on top is the rise, the number on the bottom is the run. So start at the point negative 2, negative 3. So that means you go left 2, down 3. Here's our point, negative 2, negative 3. And we want to use a slope of 1 over 3. So that means it goes up 1 and over 3. So we go up 1, over 1, 2, 3. And then we can do it again. Up 1, over 1, 2, 3. And you just kind of keep counting using that slope until you've plotted a couple of points. They should all fall in a nice straight line. And then we connect them with a nice straight line. Remember, your line always cuts all the way through from edge to edge of your graph. But that slope is just saying up 1 over 3. Next one, we're going to start at the point 0, 4. So 0 and then up 4. So 0, 4. And we want a slope of -2. Remember that last one we did just a little bit ago, where it's simplified to be a whole number? Well, slope needs a rise over run. So -2 can be written as a fraction as -2 over 1. A negative number means it's going down by 2, and then the denominator is always positive, so that means going to the right. So rise, down 1, 2 over 1. Down 2, 1, 2 over 1. Down 2 over 1. Down 2 over 1. Do as many as you can, and then you come back and hopefully you can draw a straighter line than I can here with my trackpad, but draw a straight line connecting all the way through those points. But you've now graphed the equation of a line that passes through 0, 4 with a slope of -2 over 1. Remember, top number is always the rise, how much did it go up or down? Denominator is always the run, how much did it move to the right? So this table shows the number of envelopes stuffed for various times. So let's go ahead and plot these points. So the first row is always your x, second row is always your y. Time, so we're going to go over to 5 and up to 30, because this is the point 5, 30. Then we have the point 10, 60. So I go over to 10, up to 60. Then 15 and 90. 15 and 90. And then last is 20 and 120. So I can connect them with a nice straight line and then find the slope. It's constant rate of change. How much is it going up and down each time? So here, it went from 30 up to 60. So 30 to 60, that's a change of 30. So don't just count squares. Yes, it's 2 squares, but you got to look at your scale. That counted up a total of 60 envelopes. Over, here it went over 2. It went from a 5 to a 10, so that's a change of 5. So 30 over 5 simplifies to be 6 over 1, or just 6 for our slope. So when you're counting on a graph, with these word problems where it's talking about real numbers, you got to make sure you're counting of using that actual change. What is the scale that they're counting by? So we can do the same thing, but without the table. We can just, or without the graph, we can just find our rate of change. Remember, our rate of change, it's not like when we found our proportional or non-proportional. You're not turning them into unit rates. You're looking for how much is it changing by. So look at the y. How much is it going up by each time? Well, it's going up by 5. So the change in y is 5. Then the change in x. Remember, it's always at y over x. Rise over run. Well, here it's just counting up by 1s each time. So 5 over 1, or just 5 for our slope. Remember, m is always used to represent slope. So you're just taking your table. How much did the y increase over how much did the x increase? So it's very similar to how we calculated our constant rate of change. Same thing. First set of data is always the x, second is the y. So start with your y's. How much is it going up by each time? Well, it's increasing by 1.5. So that goes on top. Then you look at your x's. How much is it going up by each time? Well, that's going up by 1. 1.5 over 1 is our slope. So it has a slope of 1.5. We really don't want to have a decimal for our slope. So 1.5 is the same as 1 1/2 or 3 halves. So our slope is 3 over 2. And you can see the same thing here. Here it went from 3 to 6, so it went up by 3. Here it went from 2 to 4, so it went up by 2. So we can still find that same rate of change, but our slope in this case would be 3 over 2.